In this video, I will be explaining about the cognitive agent and the code base, how we created the cognitive agent and the working of that same thing. And we have taken a logistic and warehouse agent as a case study. So, what is cognitive agent? Cognitive agent is basically intelligent software, or we can say agent, which can basically think like a human, and it has inbuilt perception, memory, reasoning, and planning and decision making capability to complete any task. So, in human, when we get some problem, when we get some work to do, so first we perceive that thing, we gather the information, we basically fetches the some information that is lying in our memory, that may be a long term or short term, and then we try to make a decision, and based on the decision we perform some action, and there can be some learnings also during this process also, but here in this case we are not considering the learning. So, similarly in this in the cognitive agent we have considered perception, memory, decision making and action. In this use case, the other example of this use case are like Siri, Alexa, some like autonomous robot, customer support system. So, the logistic and warehouse automation agent. So, what we are doing over here, so we have prepared a list of questions, and based on that thing we will be basically making question to the LLM, and it will in turn use this short term memory which we are storing during when we start the application, like location, type of the warehouse automation, and the amount of the quantity, and based on all those parameters basically it will try to analyze that thing with the help of LLM and making a frequent call, like it will be making a multiple calls to LLM to fulfill that request. So, it will break down that thing into multiple tasks and make that call one by one, and in that thing it will may call some other tools which will do some specific type of work, like for example like for KPI thing. So, it will basically call some KPI tool to break down the details of that thing, or it can use some separate prompt or specialized prompt or specialized matrices to calculate all the things. So, internally we are using the MCP tools, also client server, to achieve the same thing. So, the structure of the project is like action, we have the agent, then chainlit application, the UI application, and inside the chainlit application we are making a request to the agent which in turn call to the perception, and internally call the decision and action to make or fulfill all the request. So, this is like the flow of the application. User will make a request to chainlit application, then it goes to the agent, then some perception will happen. It will basically take the system prompt, and based on the system prompt and the initial query it will figure out what are the tools that needs to be called, and then the agent, then it will make a call to the different, it will make a decision and call multiple tools, and it will call the MCP server, model context protocol server, and perform the entire action, and that way the result will get the result. So, these are the code snippet. In the perception basically we are taking a system prompt, making a call to agent. Then in the decision we are parsing we are parsing the LLM response based on the different type of function call, and breaking and adding the arguments also. Similarly, in the action, based on the decision we have decided, we are taking specific sort of action. So, initially the action has to be, we need to start the MCP server for that thing, and once the MCP server is running, it will call to the client will make the action is basically a MCP client which will make a call to the MCP server, and which will perform different type of action, like using different tools over there. And it has the memory also, short term memory. So, the initial data that we are gathering from the user, like warehouse, what are the daily shipment and type of automation. So we are storing on this thing in form of a dictionary. So this is a short term memory over here. We may can use a long term memory also, like in form of a database or something like that. So this is one simple logic for the MCP server. Like here basically we are asking to suggest 5 KPIs. So it is making call to LLM, and it will give what are the best 5 KPIs for the logistic and the warehouse management. Similarly, there might be some calculation also that can for some matrix calculation for the warehouse, or there some route calculation also might be there. So there might be a different type of logic, or we may call some third party API, or there might be something like a mathematical calculation happening over here. And these are the different categories that we are serving. The one is a logistic, inventory, training, sorting and packing, and safety process. So what I will do, this is some example query is there. So this example query, so when the application start, basically what happens in the application is start. So it will basically ask for the Gemini key. So once we provide that key, then it will ask for the location, warehouse location, then what is the volume of the shipment volume, then what is the level of automation, and then we can ask the question, and this is the final answer that we are getting. So I have asked the question, what are the top 10 KPIs you recommend for tracking the efficiency of a warehouse operation. So these are the different KPIs it has suggested, like accuracy rate, order accuracy rates, on delivery rate, on time delivery, warehouse throughput. So these are all the things they have suggested. So now the application is running. Now this is the application which is running at a localhost 8000, and we can see that we can see from the logs that just now it has generated the output. So I will ask one new question over here. Suppose I ask a question like, what KPIs are critical for evaluating the performance of a warehouse picking process? Suppose if I ask this question, so the call came to the application, it is processing, it is making a call to LLM, and here we can see this has broken all the things into the different function call. So multiple calls are happening to the LLM, and then once we make the first call, then it will make a tool calls over there, and once we get the final output, we will be making call to we will be again making a call, and where basically we will be merging the call for first call, that is a system prompt. When we make a call to system using system prompt and initial query, the output that we are getting and the final output that we are getting, so those things will be merging and making a combined call, and that final answer is shown over here. That this is the final answer that is getting shown over here. So here we can see that we combine at the end we combine all the all the initial call to the initial response of the LLM. So this is the initial response, and this is the final result that we are combining, and then we are giving the whatever the output we are getting, we are giving to the UI, and these are the steps like whatever I explained. First is the perception, make decision, then action, and then finally combining the perception and action output. And here we got the answer. So the final answer is that order fill rate, inventory turnover rate. So these are the some top 5 matrices which will help to monitor the warehouse. And in future I will be improving this thing. I will maybe adding some backend over there to improve that persistent memory type of thing. Thank you.